Okay, so inside the crucible, we threw some iron wire. The mass of the crucible, so the pre-mass was 56.346, and then the mass of the crucible and the iron wire was 56.904. So what is the mass of iron that we used? How are you going to calculate that? If you know the mass of the crucible, you know the mass of the crucible with the iron. How much iron did we use? Yeah, you just subtract them. So 56.904 grams minus the 56.346 grams gives me the mass of iron, which turns out to be 0.558 grams. That's how much iron we used. All right. So then we heat the heck out of it. Okay. At the end of that reaction, so it reacts with the oxygen in the air, we get this oxide, iron oxide product. Okay. So how much oxygen was pulled from the atmosphere? Right. This is the mass of the crucible with the iron oxide that we produced. So if I want to know the mass of oxygen used, it's going to be this one, mass of the oxide product, which is 57.144, minus the second number. Okay? Because I just want the oxygen. I want to know how much oxygen was pulled from the atmosphere to react with the iron. So minus 0.6904 grams, because that has the iron factored in as well. So this is 0.240 grams of oxygen. All right. So now I know the grams of oxygen and I know the grams of iron. All right, that we're using in this experiment. How do I figure out, what are they asking for? The formula. So essentially we're doing the empirical formula. So do we like grams? What units do we want? Moles. So we got to convert find the moles of iron. What's the mass of iron, or the molar mass of iron, I should say? 55.8. Oh, that's convenient. So 1 mole of iron is 55.8 grams. So if you divide that, you're going to get 0.01 moles of iron. We also want moles of oxygen. So that's going to be the grams of oxygen, 0.240 grams. 1 mole is 16.0 grams, which gives me 0.015 moles of oxygen. All right. Which is a smaller number? Point 0.01 is a smaller number. So that's what you divide by, right? This is the moles of each one. So divide by 0.01 gives me 1. Divide by 0.01 is going to give me 1.5. So if you wrote it with the fractions, it's going to be Fe1, I'll write it, O 1.5. Does that make any sense? Can you have 1.5 atoms of oxygen? So how do you get rid of the 1.5? Yeah, you're going to multiply everything by 2, right? So you're going to get Fe2O3. So this is an empirical formula question with one little extra wrinkle. It's got all the crucible data, right? So the raw data from the experiment. The other thing I asked for is what is the name of this compound? So if you remember naming, you're going to reverse the charges, right? So it's like Fe plus 3, O negative 2. So what's the name of this compound? Iron 3 oxide, because iron has different charges. So it's iron 3 oxide. So it's the exact same as an empirical formula question that we did at the beginning of class, except you're just given this stuff. Okay? So the only trick is figure out how much iron you used, which is this one here, minus the mass of the crucible. The slight trick is figure out the mass of oxygen that has been incorporated into it, which is going to be the total product weight minus the mass of the iron and the crucible. So I don't want to know how much iron oxide is there. I want to know how much of oxygen is there. Okay? Are there any questions about that? Once you know the grams, then it's just a convert to moles and divide by the smallest number. There's one of these questions in the practice I'm going to give you today. Tomorrow I will start the class with another one of these questions, and the review will have another one of them as well. For the rest of the block, I'm going to give you a review to work on. I'm going to collect the reviews. I'm going to collect 2 reviews because we have 2 blocks to review. They are the easiest marks you will get in this class. Okay. I will go over the labs probably tomorrow because I got to still enter them. What did I do with the reviews? All right. Here's first review. I will put the key in the classroom. Okay. There are other reviews in the classroom if you want extra practice with keys attached. But I will give you another review tomorrow and outline what the test is going to look like tomorrow. Okay. You get your data package, you get a calculator, you get all that fun stuff. Please ask questions. Oh no, it worked. Shouldn't come to school then.
I wish I could get a receipt. Yeah, but that was
You like calculus
I will like calculus.
because you'll be challenged. I think I know who the prof. Well, they haven't hired yet, but I think I know who it's going to be.
Is it a good one or a bad one?
He's good, but he's tough.